going to make sure, yes, we have sound. Good evening. Boy, this is a nice big class. I'm glad to see all of you here tonight. I'm Levi Waldron, and I'll be giving your lectures for this semester. You also just saw Professor Tony DeVito, who's going to be doing the last sections of the course. So I'm going to start out just by mentioning, as you can see here, I've just started recording. There's no video on here, so even if the back of your head is in the camera, it's not doing that. I'm just going to be recording a screen share and the sound. So for tonight, you're all here, but if you want to review something that we talked tonight, it will be here, it will be recorded, and I will just show you how you can do this. So going to the Blackboard page, I'll show you first under weekly materials. You'll see for each week we'll post a folder here. There's session 1 under the lecture materials. You will see here the lecture materials themselves, and you'll also see a link here to a page on YouTube. And we are recording live right now, and then it will still stay there at the same URL afterwards. If you click on here, you'll be taken to a channel that says BIOS 611, just because I didn't feel like creating a different channel. You have to jump through a bunch of hoops with YouTube to get your channel verified and everything. But if you go there, you will always find the upcoming lectures and the recorded lectures. Subscribe to it or not subscribe to it, but they will be there, and they'll also be linked to from this page in Blackboard, from each week's lecture pages. So I'm going to start out with our learning objectives for today, and I'll introduce myself. And a little bit more about my research interests, and talk about the course, and then we're going to review the syllabus. So our learning objectives for today, we'll have quite a bit of general stuff. The first one objective is to be able to find this lecture room. That one I almost failed at and went to the wrong lecture room, but I made it here, and all of you made it here, so we've all succeeded in number 1. Congratulations. We'll talk some today about pros and cons of SPSS and our software. SPSS is a menu-driven software that Tony will be using in the lecture or in the lab portions this semester. R is a programming language, and the one that I use for my research. We'll talk about it more during lab session, and you'll have a chance. Usually when I've taught this course before, almost everybody will use SPSS. It's an easier software for getting started with, but I have often had a few people who wanted to take the dive and either they've already used R for something, or they want to learn it. And it's certainly something that you can do for this course. And I'll be interested, maybe later on during lab session, I'll get a show of hands to find out if there are any papers for R, and if there are, I'll make sure to post some resources for people using R. It has the advantage of being free software, so after you finish being a student and no longer have access to the free SPSS license that we have through the school. Is it free now, Tony, or are they still having to?
It should still be working this semester. There's a link where you can download it, and okay. I think one of the students already did it, because they asked me got a question about the registration number. So you can go, the link is on Blackboard. I'll mention it when we go to the lab session. You can download SPSS. The license should be good at least until the summer, so you won't have to pay for the program.
And it's okay while you're still a student. After you graduate, it costs like $1,000 a year or something. It's ridiculous. But as long as you're academically affiliated, it's reasonably free or So we're going to review the syllabus, important things from that, and then get on to our first bit of actual statistics with types of data and some important types of tables and graphs. So I am going to review the syllabus, but on this slide I just want to mention what the official required textbook is. And I say it is required here, but I said it was optional on CUNY first, and that because it's actually a free textbook. You don't have to buy it. You can go to this web page and get a digital version for free if you don't mind reading it on a screen or something. But the print versions, if you prefer, are quite cheap. It's a free textbook. These are just the costs of printing. And we moved to this textbook several years ago, not only because it's free, which tends to be popular, but it's also an excellent textbook. To my mind, it was a big improvement over the $100 textbook that we were using before that. It's concise, it's clear, and it's modern. It goes through frequent updates. It gets updated almost every year, so it's up to date. It's a very nice textbook. So I'm going to go back to Blackboard. Let's see where. Here we are. And just show you on the syllabus page, I've done another digital thing here, which is to create a course calendar that is actually here in Blackboard. So if you want to see the dates of your exams and the dates when we don't have classes, it's in the syllabus, and it's also here on this calendar. And you can import this calendar into yours somehow, I believe, by clicking on this plus or something like that. So here's the syllabus. I just updated this. Tony posted it there on the weekend, and I just updated it before class because it actually before had a class scheduled during the April recess, which is fixed now. So if you've downloaded it already, make sure that you get the updated version. You'll see it has today's date in the title, and also on the subsequent pages it says last updated, and it's today's date. And this has, I believe, the correct dates for everything. So, as I mentioned, we're using this Open Intro Statistics textbook. You may use the software of your choice. Everything that we're doing in this course can be done really by any commercial statistical software. Most of it could even be done with Excel. You'll be getting some familiarity with Excel as well. But the primary language of the lab sessions that we'll be using in class is SPSS. But again, if you're interested in using something else, just let me know, and I'll make sure to provide some materials for supporting that and do the best answering your questions as I can. I'm not going to go through all of the course competencies and learning objectives. There are lots of them, but this is a broad introduction to statistics. We're going to spend several weeks just talking about types of data and visualization and exploration of data. We're going to cover inference, hypothesis testing, several common types of statistical tests, and it's really intended to take you from, we have no assumption of you having taken a statistics class before, to having a fairly broad introduction to statistics and the underpinnings and common applications of statistics. So the grading is going to be based 30% on homeworks. So do your homeworks. These are probably the most important and the easiest grades that you can get in the course. If you put in a decent effort at the homeworks, you'll probably do quite well at them. You will probably also be given multiple attempts on them to see where you went wrong and redo the assignment on your own before the due date. So I strongly encourage you to attempt the homeworks before the due date and give yourself a chance to redo them. Tony will talk more about that. He is in charge of the homeworks. You will have 2 exams worth 15% each, so cumulatively they're worth the same as the homeworks. These are I will say not as probably not as easy to get 100% on or do very well at as the homeworks. However, they will be based on the same material as the homeworks and the lectures. So I'm not going to put surprises in the exam. They'll be based on the things that we cover in the lectures, in the labs, and in the homeworks. However, the exams are going to be open book. I will allow you to use any of your notes, any of the class materials, only not using the internet during the exams, but using anything that you want to bring into the exam, which is, I think, a more realistic assessment of how you will apply statistics in the future. But it also means that I have to throw you, a few kind of different things to test your ability to apply the things you've learned to some different problems. So this is where being well practiced with the assignments and familiar with the concepts that we've talked about in class and the exercises that you've done in the lab sessions will serve you well. And then finally, at the end of the semester, we're going to have a final project worth 30% of the grade. So it's sort of 30, 30, 30 for homeworks, exams, and a final project. The final project will be a data analysis. We'll give you some data sets that you are welcome to use that are good subjects for an analysis. But for your final project, you're also welcome to do any project that you want. The idea will be to perform a data analysis using some of the competencies that you gain in this course, do statistical analyses, visualizations, and present these in a poster format to the rest of the class at the end of the semester. And there will be more details as later in the semester on this final project. And finally, this class participation of 10%. As Tony mentioned, this is going to be a hybrid format class, so you're not required to be here in person other than for today, the 2 exam days, and the final project. So, so it's hard to grade class participation in that format. So what I do for this is grade this only during the final project. I'm going to create some discussion groups and ask you to post the components of your project at certain interim deadlines and then provide feedback to your peers in these discussion groups. And just posting the components of your project by the deadlines and providing some feedback to your peers will be what the class participation is based on. That adds up to 100%. Are there any questions yet? This is most of what I'm going to cover. I'll do just a little bit of review of the rest of it. Yes?
Do you have your class recorded? Because this is my first time in person. I used to take the online. Your previous semester, would you have the classes online? Recorded?
Yes. So we're recording right now. The classes will all be streamed live. There's a YouTube channel they're linked to from Blackboard, and you will be able to watch them as it is occurring or afterwards watch the recording. Course policies. Oh, I should mention I will create a Google group. I'll talk about this. We'll determine this for sure in the next week whether we're going to use Blackboard or Google Group. I have tended to find Blackboard a bit clunky for the discussion groups, but it underwent a bunch of renovations since last semester, so I'll see if the discussion groups are a little easier to use than they used to be. We'll use either that or Google Groups, just as a way for you to ask questions that are of interest to the group, like questions about the homeworks, about the subjects in class, things that are useful for everyone to be able to answer. Lateness, there is a penalty for lateness, but better late than never. And generally, if you have a good reason for something being late and it doesn't interfere with the grading, we'll just grant an extension. But in general, it's 10%. It's 10% per day. Let's see. Okay, I'm going to skip down to the schedule. We'll have our first 2 classes and then a week off. Our first exam is not too far away. It's in our fifth class, and the idea here is to make sure that you don't get too far behind at the beginning of the semester. So keep up, because your first exam is not very far into the semester. And then our second exam is not too far behind that either, a month later. So the first exam is going to cover these topics. The first 2 classes are all about types of data, data summarization and visualization. We'll have a class on probability and diagnostic tests, and then finally a lecture on probability distributions and some types of random variables. This is not confirmed yet, but hopefully we will get a guest in from the Department of Health and Mental Hygiene to give a talk on the Department of Health and Mental Hygiene data resources. So we do have one other missed Tuesday on April 23rd for the spring recess, and the final project will be on May 21st. Finally, I just wanted to point you to a handy cheat sheet that I gave you on the back page about statistical notation. And this mentions some of the conventions that we're going to use in this course about use of Greek and Roman letters and what the symbols that we're using. But I won't get too far ahead of myself with that. So just a bit about me. I am an associate professor, full-time faculty here at the CUNY Graduate School of Public Health and Health Policy. I have an active research program in topics in high-dimensional statistics. These are areas where we have more variables than observations. Nothing that we're going to get into this semester, but it's something where, for example, you can have data on 40 people, like here, but have 50,000 variables measured on the 4 people. It's the type of data that is generated by genomic sequencing and types of technologies. Predictive modeling is the act of taking data like those and trying to predict some outcome, like survival in cancer patients and recurrence. this is something I've done a fair bit of methodological work in. The general topics or areas that I work in are cancer genomics and human microbiome studies. And if you want to see more about what I do, I have my personal web page at walterlab.com. I wanted to mention that I organize this statistical learning book club, and occasionally data competitions. I don't think we have any of those coming up, but this book club has been popular in past years. We go into topics that aren't covered in the program, but try to stick to readings that are fairly conceptual and not too mathematical. And I am planning on starting up the book club in March this year. And I do this in collaboration with a statistics department at the University of Salzburg in Austria. So if you're interested in statistics and you just want to learn something more, this is online, and you can just attend and read sections of the textbook that we'll cover and discuss it during these meetings that we have. And I'll just mention that I do occasionally have research opportunities available, especially to students interested in cancer genomics or microbiome studies, looking to do their practicum or capstone studies, and depending on backgrounds, I sometimes have research assistantships available as well. So briefly, our expectations for you, first of all, our lack of expectation is about prior knowledge of statistics. So I assume that you have the course prerequisites which do not include statistics and nothing else. So I'm going to start from basics, and I will ask you to ask questions. Sometimes I might accidentally skip too far ahead and assume some prior knowledge that you don't have. I really want you to feel comfortable speaking up and just asking. It enriches the class, and I really welcome such questions and opportunities to go into further discussion about the materials. We expect that you'll be interested in being able to do practical data analyses using software. That's a fairly major component of the course. So the lectures are generally going to be fairly conceptual. We'll be talking about the ideas, the theory behind what you're doing. That's 1 hour out of 3. Then another hour and a half or hour and 40 minutes is going to be hands-on learning how to apply the things, the concepts that you're learning. You can expect us to go from 5 to 7:50 p.m. promptly. I might sometimes start a couple of minutes late, but it's pretty prompt, and we will also make sure that you get out of here promptly at 7:50 p.m. You can expect for me to be available either through our discussion group, whether that ends up being on Google or on Blackboard, for questions of general interest. So if you have a question about I don't understand this homework question, or what's going to be on the exam, or things like this, of general interest, I really prefer to answer those questions to everyone, because if it's on your mind, it's on several other people's mind. And I have found in the past that when I answer questions like that individually, I just have to answer them over and over again, and I can't manage it. So if you email me a question of general interest, I will probably email back and say, would you please ask this to the group so that I can answer it for everyone. I am, however, available, of course, by email for questions about yourself or of individual interest. If you have a problem and you can't be there on the exam date or something, email me and Tony as well. Email us both, and we'll figure something out. I don't hold office hours because I've found it's too difficult to find a time that that works for even a majority of the class, much less anybody or much less everybody. So what I've done is made this fairly easy to use appointment system. You just go to calendly.com/lwaldron. You'll see times that I'm available. You can just click one and make an appointment for yourself, and we can be either in my office or you know, our options there for meeting. And most of all, you should expect a supportive learning environment from us. So you don't have to be afraid about asking a stupid question. Feel that really our primary objective is for you to learn in this course. And we'll do whatever we can to make sure that you don't get left behind and that you have the opportunity to learn in the way that works best for you. Are there any other questions before we move on to some topics in statistics? Yes.
Is there like a break between lab and lecture?
Yeah, we'll have a 5 or 10 minute break between lab and lecture. Also give us a chance to switch the technology over. We use different technologies for the lab and lecture. And in case, for the couple people who were a little late, there is a sheet going around that is a verification of attendance. Make sure you sign it because we will use that to verify to CUNY first that you are attending the course. And if you have financial assistance or scholarships or anything, it's very important that you get credit for attending the course. So if you haven't seen that sheet of paper, find it and just sign your name next to where your name is on there so that we know that you are attending the course. It's up here. So it looks like there's still a couple of people not signed. So if you're here and you haven't, okay. So we'll pass it around again. All right. So any other questions? Yes.
What if we already did the course in the protection of human service? Will you accept the certificate?
Yeah. So
If you have a certificate that's less than a year old, otherwise we ask you to take a refresher. Reason for that is, what we're talking about is that one of the requirements of this course, I'll be talking about it later also, is to complete an online course. It takes about 5 or 6 hours. In ethics and human research. I'll give you details later. Presumably, as you move through the program here, you may be in a situation where you're working with human subjects or you're working handling data that's from human subject trials. So in order to make sure you qualify to do that for Hunter, for their review system for Hunter for research, we ask you to complete that course during this course. If you've done it with another institution, it should be okay. You can send me the certificate, I'll check it. If it's more than a year old, we ask you to take a refresher. I think usually the period for this is about 2 years, something like that, renews every 2 years. But the problem is if it's like a year and a half old, and it's got 6 months left on it, you'll be taking other courses here. So just email me. If you take one already, email me, I'll let you know. It's okay.
yeah, that's not a bad thing to get out of the way early in the semester before things get too busy. You can probably do it in less than 5 or 6 hours, is my experience, but it's interesting. It depends on how much time you spend reading it. Yes?
When we complete it, you'll know that we complete it, or?
Yeah, there will be an assignment where you can upload your certificate. So you'll complete it, you'll download your certificate of completion and upload that to Blackboard. Yes?
So we'll be in class about a handful of times. Those times will we need a personal computer?
You know, I didn't realize that we're in a room without a lamp.
Yeah, so what you can, you will need a computer for the lab session. What you can do if you don't have your own or don't want to use your own or want one that has the software already installed on it is before class, stop by the IT on the 5th floor and sign out a computer.
Do you guys plan on putting outlets in these desks, or is it just going to stay?
I think I stole the only seat and out there next to it. Right.
I'd like to record you asking this question and take it to the.
Yeah, I think you're only going to need to be charged up enough for about an hour and a half.
Yeah. So you know what I think I'm going to do this semester is buy my own extension cord. Because it's an issue. It's been an issue since we started the building. They're out there. These lovely outlets in the desks. They don't work. And I'm really sorry about that. But it is apparently difficult to fix. I don't know, but I think there is maybe a cheap solution that involves this and some extension cords that I'll be able to enact so that at least you can charge your laptop. Very good question, and something you should feel free to mention in your evaluations as you go through the program that this would be convenient. Yes.
Just one more question. In terms of the exams, are we anticipated to have any sort of similar to the lab where we might need a computer, or will it all be on paper?
No, the labs will involve using a computer as well, and will involve the software. So the exams will involve using your computer and the software as well. So there will be some that are just like, think about it, write some stuff down and answer, but also some that are like, here's a data set, do some analysis, and then answer.
But for those exams, we wouldn't bring our own, right? We just use whatever.
You can bring your own if you want. Yeah, yeah. I don't mind. You can really, for the exams, bring anything you want. It's open book, open computer. The only thing that I require or restrict in the exam is say don't communicate with anyone else and don't be going around on the internet looking at new things. Just limit yourself to what you bring to the exam. But I'm very liberal about what you can bring to the exam.
Okay. Thank you.
You're welcome. Great questions. You're catching all of the things I forgot to mention. Yes.
So I just want to confirm. So the next time we're going to see each other is March 5th, right?
Well, no. So we will be here, and I'll be standing here giving this lecture. And you can come or you can watch online. That's up to you. So if you that's what we mean by hybrid course here. I'll be here giving a face-to-face lecture.
Okay.
So if you prefer the in-person format, then by all means come in and participate in person.
And for the lab, so every week can come in person if you want, every week for both the lecture and lab.
That's right. Every week for both the lecture and the lab, you can either come in person or you can attend remotely. And the question asking, my experience is it's a little bit smoother in the lab section with the software that Tony uses, but I will during the lectures check for questions. There is the possibility to ask questions through YouTube as well. Yeah. Yes.
How does the lab work over if you're not in person?
Yeah, if you're not here in person, the lab works just the same way as it does if you are here. You will have a computer there. You'll need to have the software installed yourself on your own computer, but there will be materials for you to download with data sets and notes. It would probably be easier if somehow you have another screen to like watch what Tony is doing while you're doing it yourself. But you can do it splitting your screen in half or something, so you're analyzing data on one half and kind of watching what is going on in the other half. But it will be just in the same way. And I mean you'll see tonight what the labs are like, but they're fairly like actively led. So you could also just watch the lab while it is happening, and then do it yourself. Go through the exercise yourself later depending on what works for you. The way I would do it would be with an external screen or a tablet or a second computer, so that I could have this screen going on while I was looking at another screen doing the analysis myself at the same time. This is how I would do it if I were doing that remotely. Yes?
If we are unable to catch for this lecture, can we continue with lab?
Sorry?
If you are unable to catch for this lecture, can you continue with the lab?
Oh, if you're unable to, if you miss the lecture, can you continue with the lab? Yes, absolutely. I think the lecture is helpful for giving you the theory about what the lab is about, but the lab will basically go over the same material, just from a more applied perspective. So yeah, if you missed the lecture, I would still join in and watch the lab, and then catch up with the lecture later. One is not really prerequisite to the other. They're just complementary. I think in the past, a lot of students have found it helpful seeing the same material from two very different perspectives, and that's really what they're like. They're covering the same material from a more theoretical and a more applied perspective. Yes?
The link provided on the syllabus to download the SPSS software, it gives us an option of also downloading SAS. Can you explain the difference and whether we need them for this course?
Yeah, so SPSS is Statistics Package for Social Sciences. It's an IBM software that is menu-driven. It also has a programming language underneath it. But the reason that we use it in this class is because it's easy. You can once you load your data set, which is especially easy if it's already prepared in SPSS format like you'll have here, you can do quite a few things just from the menus. SAS, the statistical analysis software, is by SAS Corporation. It's a very old but still widely used piece of statistical software, and it is not menu driven. It's a programming language, and it is broadly used in epidemiology, less so in other areas of public health. So if you were in the epidemiology and biostatistics stream, you would find that in your subsequent epidemiology courses, they would all use SAS. For other streams, you'll probably not use it. SAS. So it's not that easy a language to learn. I think it's considerably more difficult than R. But yeah, unless you are in epidemiology, probably don't need SAS. Yes.
So if you want to devote
Mm-hmm. So if you are really keen and you want to learn, did you say SAS and R or SPSS and R? Oh, okay, SPSS and R, that's easier. I thought you were talking about like 3 languages. So if you want to learn SPSS and R, what I will do is first give you some help with CUNY provides. Well, R is free software, but CUNY also provides, or Microsoft provides, you don't even need to be affiliated with CUNY, a remote desktop machine that runs R for you, and I can help you get you set up with that and point you to some learning resources. what we can do during the labs, I can say, is if you kind of go like this, I can come around and try to help with our questions. But the sort of lead material will be using SPSS. But I love R. It's like I use it all the time, so I'm always happy to do the best I can in supporting people learning it as well in this course. And it's not that hard. Yes?
I just think that's what I threw up for a second. When we take the break for the lab, you can go down to the 5th floor and check out a laptop if you don't have one with you.
Yeah.
The good thing about that is that there's a little process to log in here. So if you're new to School of Public Health, they'll show you how to log in as well when you check out the laptop. Okay, so those of you, I warned them, I told them about maybe 15 people might come down there and overwhelm them. But when we take our break, go down there and wait till you guys get back here. And you'll be able to see the process of logging in lab sessions.
So yeah, you don't have to do it before class. Even if you get here just before class, you can also sign out a laptop during the break. Any other questions? All right. Well, you'll have lots of chances to ask questions at later times or any time during the class if you have questions about the topics. So I just thought I would start out with a dumb question of my own of what is statistics, because there's actually different perspectives on what statistics are. And if you go out to the general public, a lot of people, when you say statistics, they think of numbers and they think of things like baseball statistics, like batting averages and things like this. So I thought it would be helpful just to clarify what we mean by statistics. And even that is not that simple an answer, because it covers a lot of different aspects of working with data. Data being the key unifying element of all of these components of statistics. So I think that the major components of statistics are design. This is the things that go on before we collect the data and planning how we're going to collect data for some study. Description, summarizing the data obtained. This is the first thing we do when we get a data set to understand what we have, because typically a data set looks like pages of numbers and you can't understand anything about it until you do some simplifying procedures and visualizing procedures to help you to understand what you have and what the properties of your data set are. And finally, inference, making decisions and predictions that account for the uncertainty of your data and the incompleteness of your data. And this incompleteness and uncertainty is a key part of statistics, and dealing with the fact that in real life, we don't have perfect data and we don't have complete data. We tend to have some small bit of data from the whole world and all of the things that we might have been able to collect if we had infinite money and infinite time. This perspective on statistics goes way back, arguably to well before the Common Era, when are the first records of someone using average values. Apparently, Hippias of Elis used the average value of the length of a king's reign to work out the date of the first Olympic Games. And like all really good statistical methods, they've been around for a long time and they haven't changed. We'll be learning averages and using averages in exactly the same way in this course. So I'm going to start with some definitions. In In this course, a population just means the entire group of interest. And this is something that's important to understand in a study because it doesn't go without saying what the population is. In some cases, it could just mean all people. It could mean everyone on Earth. But it could also mean American adults. It could also mean just residents of New York. It could also mean just adults or children or incarcerated adults. It could mean any number of things, but it is a group of people who are of interest to the study at hand. So for example, this was an article I saw a few years ago, and London was voted one of the world's favorite cities in the largest ever global survey of its kind, covering 18,000 people in 24 countries. And in spite of the headline, because this was from The Guardian, not from the New York Times, New York was the favorite overall and the best city to do business according to these people. But in this example, what is the population that this company Ipsos is studying? It's a non-obvious question. Yeah.
So they're basically the survey is only talking about. It's like the largest. Yeah. So it's the largest global survey. It's not necessarily talking about like the people who actually are voting for London as like their favorite. It's just like it's been voted like one of the favorite amongst like the surveys that's like the largest of the world. Like what about the smaller surveys? You know, does that make sense?
So certainly a smaller survey could come up with a different result than this.
Like the subset would be the global surveys, not all.
This is just one survey. I mean, they've performed their survey in a lot of different countries and to a lot of people. I don't actually know what their methods were here. I don't think that they're like surveying smaller surveys. They're directly reaching out to people and asking them this question. So my question here of what is the population here, you could argue that maybe the population is the people in these 24 countries. I think though that their intended population here is the whole world. And these 24 countries are selected as a sample of the countries in the world, and these 18,000 people are selected as a sample of the people in those countries. So it's intended to be a worldwide survey, and it's trying to make an inference here about the preferences of everyone in the world. You look doubtful. Yeah, I mean, a lot would depend on how these 18,000 people were sampled. If they put a web page on the internet and let it spread by Twitter, then there's going to be a lot of questions about the validity and the representativeness of this sample. But I think it's clear from the statement here, the world's favorite cities, that their intention is that they are surveying the population of the world. Intention. We'll talk more about some issues with sampling and validity of sampling. But for now, just what's the population? In this case, the population is the world. So I highlighted the definition of sample here because that is what is being taken. It's just a subset of the group of interest. So if the group of interest here is the whole world, obviously you're not going to ask this question of several billion people to ask everyone in the world. You ask a sample. And a lot of statistics is about the analysis of samples, which are an incomplete subset of the population of interest. If you do survey the entire group, that's called the census. So by entire group, I mean the population of interest. And a single observation is often called a record. So this, in here, the population is the whole world. The sample is these 18,000 people from 24 countries. And each of those 18,000 survey responses is a record. I'm going to start with our discussion of statistics with descriptive statistics. I'm going to skip by for now design, which is actually more complicated than descriptive statistics. We'll have a little bit of design later, but I'm going to bet that most of you are going to come in to analyses at the point where data already exists, and you need to analyze those data. And that's how we're going to start here. The value of descriptive statistics is that it takes potentially complex data, certainly or most probably numeric data, and puts it into a format that you can digest and read and understand without having to directly look at those raw data. This is a very famous descriptive statistic called the conquest of pestilence in New York City that is famous because it has enough data to write an entire paper about, contained in this one paper, and done without even the help of computers. This is a hand-drawn graph. Even the axes here are drawn by hand. And in this graph, it's showing the death rate per 1,000 population over time, and it allows you to see both long-term trends and the short-term spikes with these nice labels, attributing those spikes to outbreaks that occurred over the years in New York City. And so you can quickly see these important major events and then see how both the background rate and the severity and frequency of those spikes has gone down and down, largely thanks to sanitation and vaccinations. Oh yeah, I mentioned sanitation and vaccinations just also to say that hopefully we will stay this way. There's been some uptick in the severity of some of these outbreaks now, still quite minor, but there is always the risk of these severe outbreaks occurring again as vaccination rates decrease. So inferential statistics, that third component that I mentioned, is about the inference on the population based on a sample. This example of Trump approval rating by multiple polls taken from my favorite source for political polls, 538.com, shows the results of all of these dots are different polls. So they actually scrape the results. So this is sort of like what you were talking about of analysis of individual studies. They curate and they standardize the results of dozens and hundreds of different polls. They correct them based on past biases that those polling companies or nonprofits have had, and then they take an average of all of them. But what they're attempting to do, so there is taking these small samples from the individual polls and averaging them so that they get an idea of, they get larger sample sizes and try to make inference about, in this case, the overall popularity of Trump in the population. So taking many small samples and making inference about the population. Who's the population in here? It's probably the population of voting eligible adults in the US. Some of the common questions that come up in this are, how great is the uncertainty? And what are the sources of uncertainty? So you can certainly see in here from all of these little dots that these polls all have some uncertainty about them. They're scattered around. They don't agree with each other completely because there's uncertainty in them. That uncertainty could be because of just the sample size. There's some uncertainty in who gets selected. There can also be uncertainty that comes from biases in how that sample is selected. In public health, these are some common types of inference that are made. Does an experimental treatment for cancer work? So we want to ask a question in general about the population of cancer patients. But of course, in a clinical trial, you only have the opportunity to test that therapy on a small number of individuals. So it requires inference to say something about the effectiveness of that treatment in the broader population of patients. Is cycling in the city becoming more dangerous? Again, no matter, even if you had complete data on bicycling accidents for year after year, there's going to be some random component to that, some sort of natural variability and fluctuation from year to year, which you will have to separate from the trend, which is what this question is asking about. Do public health issues differ across the city? That's kind of a big question, but one that could come up in different contexts, asking what the let's say the major causes of hospitalization are. If we were going to do an analysis about this, this question would have to be made more specific and made into things that we can measure and write down what the population, the sample, and the records are. So that brings me finally to actual data that we're talking about. And I'm going to separate the data that we work with into 4 types: nominal data, ordinal, discrete, and continuous. And I'll talk about all of these in a little bit more detail. Nominal data I use for data that are binary or dichotomous and categorical. What do I mean by that? Well, binary or dichotomous means there's only 2 possibilities. A couple examples could be in a clinical trial, the control group and the treatment group, or if we're talking about health outcomes, people who survived a certain length of time and people who died in that same length of time. So things where there are only 2 options. Categorical are also what we call nominal. We call them nominally because they're nominally numbers. They're not really numbers. They're something that we need to write down and use words to describe, like control, treatment, alive, dead, or blood type, AB, and O. And if we write numbers for them, like 0, 1, 2, 3, 4, those are not really numbers. They're just representations of something that is a qualitative variable. So they're only, if we do represent them as numbers, they're only nominally numbers. You can remember it that way. Ordinal data are similar to nominal data in that any numerical representation that we have are not really numbers, but the difference in ordinal data is that there is a natural ordering to those categorical or qualitative variables. So an example is this Karnofsky performance scale that assigns a different score for how mobile a patient is, from a 0 that is fully active, a 1 not quite fully active but can still do light work, down to no work, only able to move less than half the time, to fully disabled and not able to move independently at all. So these are still not, they're only nominally numbers, but they have an order. So we call them ordinal data. So in ordinal data, this order is important, but the magnitude is not important. So the fact that I call these 0, 1, 2, 3, 4 is not important. I could have just easily called them 1, 2, 3, 4, 5. And the differences between them don't mean anything. So the difference between a 0 and 1 is not the same thing as the difference between a 3 and a 4 here. Those differences mean something in real life, but they're not, you can't just subtract them. Ranked data is an important type of ordinal data. So if we talk about the order of finishers of a race, or the order of a quantitative variable, like which is the largest number, the second largest, that is a type of ordinal data, and one that can come up frequently. Just to give another example, yes?
Sorry, what was ranked data?
So ranked data is, this is an example of ranked data, where I have the number of deaths by the 5 leading causes of death. So this is an actual numeric variable, the number of deaths in 2010. The rank is just the order of them. So when I say heart disease was the leading cause of death in 2010, cancer was the second leading, chronic lower respiratory diseases was the third. Those are ranks. So just like any other kind of ordinal data, the magnitude, and it's quite obvious here what I was talking about, how subtracting the ordinal variable is not meaningful, because as you can see here, there's not very much difference between heart disease and cancer. There's almost the same number of deaths, but the drop from 1 to 2 is much smaller than the drop from 2 to 3. So the differences don't matter in ordinal data, only the order. So discrete data are the first ones where these are actually numbers, proper numbers in the sense that we can perform arithmetic on them. And discrete data include integer data and count data, such as these actual numbers. So these would be a discrete integer data. This is the number of deaths, so it can't take on decimal values. It can only take on these discrete numeric values. This is a little bit hard to see here, but I only wanted to point out here that this discreteness becomes less important as we get to larger and larger numbers. So in this case, yes, the number of deaths by these major diseases is discrete, but those numbers are so large that it behaves almost like a quantitative variable. And if we were to look at the rates, so the number of deaths per 100,000, it would still be discrete, but it's no longer an integer value. It could take decimal values at that point. And I also just wanted to point out how here the numbers 1, 2, and 3 causes of death are the same every year, but these 4 and 5 are switching back and forth quite a bit. So in spite of the fact, this is from the Centers for Disease Control, this is, and they're based on death registries. These are fairly reliable counts, but there's still some switching back and forth. What do you think the reason for that is? Is that because, so it's, most of the switching is between diabetes, chronic lower respiratory diseases, and stroke. One time in here, there's unintentional injury. Is that because the risk of diabetes is going up and down on odd years? Probably not. It's because there's a random component to it. So the things that contribute to any individual having diabetes or dying from diabetes or stroke in a given year have a component of randomness to it. So part of it might be predictable based on their current state of health and things that you could actually measure and give them a prognosis about their likelihood of survival, but part of it at any given time is random. And that's why we see this kind of flipping back and forth from year to year, because these are fairly close and all of these individual outcomes have some component of randomness. So it's a random variable. Sorry, I forgot to skip through my my pop-ups there. So finally, continuous data. And the classic types of data that we mean when we say continuous data are things like time, weight, length, and mass. Things that can take decimal values and in theory can take any value within a range of possible values. So unlike discrete data, which can only take certain values, these can take any value. And they might be bounded to a minimum and a maximum, or just a maximum or just a minimum, or unbounded, where really any value is possible. So generally, time is usually bounded, weight is bounded, 0 is a minimum, length and mass also have 0 as a minimum. But within those bounds, all values are possible. So unlike nominal and ordinal data, but like discrete data, the magnitude actually matters and the rules of arithmetic apply. So you can multiply, add, subtract, and divide these numbers. I'm going to talk a little bit about how to summarize these types of data and just try to emphasize that summarization of data or description of data is very important and something that needs to be done for every data set that you analyze seriously. If you skip this step of summarization and description and go straight to inference, you risk missing the obvious in your data set. You risk you don't give yourself the opportunity to apply common sense and understand whether these data match your prior expectations or whether they're surprising, and the opportunity to see whether the results of your analysis match what you would have thought just by looking at the data. And I will say that the more experienced you become as a data analyst, the more you learn from descriptive analysis, and the less likely you are to be surprised in the inference stage. And more the inference just becomes a confirmation of what was fairly clear to you in your description of the data. I'm going to divide these into numerical study, or numerical summaries and graphical summaries. So first, for nominal data, You can do this with a pie chart. It's one of the most commonly seen types of descriptions of nominal data. This one, what's wrong with this particular pie chart? We've got yes 87% and no 13%.
It's by implying today.
Yeah, it looks like 50-50, but it isn't. You don't get to find from the Westmoreland Gazette. I can't remember how I found this. I think it got mentioned on a statistics teachers forum that I frequent. So that's a bad pie chart, but in general, statisticians really discourage the use of pie charts. And that's because really anything that you can show in a pie chart, there's more quantitative ways of viewing it. I'm going to start with a numerical summary called frequency tables or contingency tables, or in SPSS, they're called crosstabs. And what these do is provide the total number of each variable. It just counts the number of times you observe each possible value of a nominal variable. So for example, we had a clinical trial with a treatment and a control group and a severity where we asked participants in the trial to rate their pain as mild, moderate, or severe. These would be our frequency table, or our frequency table, or what did I call them? Contingency table. All it is a count, 50 treatment, 50 people in the treatment group, 50 people in the control group, 20 people with reported mild pain, 30 reported moderate, and 50 reported severe pain. So it's a fancy name, but it's not really a fancy thing, the frequency tables or the contingency tables. Those were what I call one-way frequency or contingency tables. This is what I call a two-way frequency or contingency table. And I call it two-way because we are dividing our observations up by two variables at the same time. So I'm dividing it up both by the treatment group and the reported severity of pain, and just counting the number of observations in each cell of this 2x2 table, or this crosstabs, according to SPSS language. And what I'm writing in the margins here are the marginal totals. They're called marginal totals because you write them in the margins of this 2x2 frequency table. And they're just the sum of, along the bottom, the sum of what's in the column, and on the right, the sum of what's in the rows. If instead of writing these as counts, we convert them to probabilities. We'll get into probabilities in a couple of classes, but here just to say that if you have 50 treatment and 50 control, that means that your probability of being in the treatment group is 0.5, and your probability of being in the control group is also 0.5. These are called marginal probabilities. So for the same reason that you write them in the margin, except they're probabilities instead of totals. On the other margin here, we have the probabilities. You have a 0.2 or 20% probability of reporting mild pain, 0.3 or 30% probability of reporting moderate, and 0.5 or 50% probability of reporting severe pain. So nominal variables we can display as frequency tables in a numeric form, but also display them in some cases as a pie chart, but you can also display them as a bar chart, which is a favored method of statisticians and many data analysts, because it gives a quantitative and very readable form of displaying these frequency tables. So I'm displaying the same information as in those one-way frequency tables here as bar charts, and showing you that we have 50 people in the treatment group and 50 people in the control group. And we have 20, 30, and 50 people reporting mild, moderate, and severe pain. The bar chart can be extended into, this is a stacked bar chart showing the proportions of people reporting severe, moderate, and mild pain in the treatment group and severe, moderate, and mild pain in the control group. So you can see here that if you're in this control group, you are a lot more likely, or there are a lot more people anyways, reporting severe pain than in the treatment group, and there are fewer people reporting mild pain than in the treatment group. So if we had done this descriptive statistic off the bat, we would see that it looks like there's maybe some evidence that this is an effective treatment for pain. We wouldn't know yet if that difference was small enough that it could be explained by chance, and we wouldn't observe it if we were to look at the whole population. But at least we can see that the data, the trend is consistent with this being an effective pain treatment. If we, on the other hand, saw that in the treatment group, there were more people reporting severe pain and fewer people reporting mild pain, we would immediately wonder what is going on. Is this a treatment that's actually causing pain instead of treating it, and want to get to understand that a bit better. And all of this is before we do any inference, any hypothesis testing. So those are methods for nominal and ordinal data. For discrete and continuous data, you can still apply frequency tables, but you have to discretize or further discretize the data first. So, so that is, you take ranges of data and count the number of records that you have in each of those ranges. And by select appropriate bins, I'm referring to those ranges. So if we're talking about age, maybe it's 0 to 10 years old, 10 to 20, 20 to 30. The appropriateness of the bins is something that you have to choose. Your software will have some automatic defaults, but the defaults might not be the most appropriate for you. It might be something that you want to override. So if we can imagine, if instead of just asking patients, is your pain mild, moderate, or severe, but if we instead had a questionnaire that involved very specific questions about the pain, like how often you feel pain, rating that pain on a scale, describing it as, is it stabbing, is it dull, is it things like this, and then combined all of that into a score from 0 to 100, that would be a discrete variable that we could then potentially discretize into these 3 bins of mild, moderate, and severe to make into a frequency table. So in that case, potentially this is an easier way to describe your data, or a complementary way to describe it with this further discretization. Of course, if you make these bins smaller, you end up with a bigger table. So this is a drawback of discretizing discrete and continuous data, in that it's always going to be somewhat arbitrary how you divide it up, and your visualization or your description of it is going to depend on those decisions. And if you make a poor decision here, you could end up either missing trends in the data, or or looking at the data in too much detail and reading things that aren't there. A histogram is a discretization of continuous data into an ordinal variable followed by a bar plot. So in this example, I've invented some of this discrete from scale to 0 to 100 pain data, but then discretized it into bins of size 2.5, I believe, here, and counted the number of individuals reporting a pain on this 0 to 100 pain score in each of those bins. And then I'm just plotting them as a bar plot with those bins in order. That's a histogram. And this histogram, you can show more data, more bins than you could practically look at in a table, but the data are the same. This is just a one-way frequency table shown visually. The same data set, if I put these into bigger bins, so these are bins of width 5 instead of 2.5, it looks different. It looks kind of the same, but you don't see that there's a missing bit here. You don't see as much sort of fluctuation from one bin to the next. I just put these notes on here, the mild, moderate, severe, to show how that, in this example, that particular discretization into an ordinal variable would be somewhat arbitrary. If I were to divide it at 40 and 50 here, there's no sort of natural breaks in this. And that is often the case of data that are discretized. So things like blood pressure. The blood pressure of individuals is often divided into like low, normal, and high blood pressure. But there's not a natural break there. Like someone at the low end of high blood pressure and the high end of normal blood pressure actually have almost the same blood pressure, and probably has no health consequences whether you're just above or just below that line. So there is data lost when you discretize that data, but the gain in it can just be the ease of presenting it and of just describing it and so on. I'll just mention that this is, you don't really need to know about frequency polygons, but this is just putting a line on top of a histogram. Not something that I do that much. This is a little bit more common. This is a smooth line put on top of a histogram to show what we call the probability density. So this just shows you the same thing that you see in the histogram here. There's a high probability density here near the middle, meaning that you're most likely to report a pain severity of around 50 and less likely to report extreme pain probabilities of closer to 20 or 80. The box plot is a really wonderful visualization because it's both quantitative and qualitative. It gives you an overview of a probability distribution in a visual way, but it also gives you some numbers. In this example, I'm putting on top of this smooth probability density, I'm putting a box plot that is an alternative representation of these same data. Just curious, how many of you have interpreted a box plot before, or looked at one and read it? How many of you have never seen a box plot? Okay, about equal numbers. Fair enough. When I got into public health, I haven't always been in public health, but it wasn't until I was a postdoc when I got into public health and saw a box plot for the first time. So it's not, you don't see them that much in the newspaper and outside of public health and academic literature. But you should know about it because it tells you a lot about a continuous or discrete distribution. So to explain it, I first need to give you a few more definitions. A percentile is the percentage of data that lie below a given value. So if I say that someone had pain severity in the 90th percentile, it means that they had pain that was more severe than 90% of the people in this study. If I say that they had pain severity at the 50th percentile, that means that it was more severe than half of the people and less severe than the other half. The quartiles are 3 special percentiles. They're the 25th percentile, the 50th, and the 75th percentile. And these are shown in a box plot. The first quartile is the 25th percentile, second quartile is the 50th percentile, and the third quartile is the 75th percentile. So when we see this box, we see that we know that half of the participants reported more than a 50 on this scale and half below 50. And we know that half of all of the people in the study, the middle half, reported pain between about 42 and about 58, something like that. This 50th percentile is an even more special percentile. It's called the median. And the median is that midway data point, the one that is greater than half of the data and less than half of the data. And finally, this interquartile range is the difference between the third quartile and the first quartile. Boy, I'm going way over time here. But we're almost done. These whiskers go out to the median plus 1.5 times the width of this box, the interquartile range, or to the largest data point. Exact plotting of the data, I'll skip by. That's just plotting every data point. It's also possible to make combinations of all of these things. I just put this in your notes because it allows you to compare all of these things. Here's a histogram with probability densities plotted over it, and a box plot, and the exact plot. So you have all of these different representations of a continuous variable here on one plot. So to wrap up, nominal and ordinal data are the kind that are not really numbers. They're only nominally numbers, and we summarize them using frequency tables numerically and plots like bar plots and pie charts to look at them visually. Discrete and continuous data, normally I don't actually make much of a distinction between these because discrete data, unless they're small numbers like between 0 and 5, its discreteness doesn't matter that much. And continuous data, even true continuous data like weight, tends to have some discretization of it due to the instruments that we use to measure them. So I tend to lump them these together into nominal and ordinal, and discrete and continuous. So I'll just note for the keen people in here who would like to try out R, there's a file included with this script that reproduces all the plots that I made for tonight's lecture. And with that, it's 6:30, so I went a little over time, but I'm going to give you 10 minutes now to go and get computers, and Tony will get set up for the lab, and we'll get started at 6:40. So it's 9 minutes.
If you have your computer log on, or you might ask them to show you how to log on to the internet, to the network, log on to the computer.